Good morning. Today we're going to be taking a look at our very last topic in the unit on discrete random variables and their distributions. We just completed the binomial distribution, and hopefully we're very comfortable with that. This final one is known as the Poisson distribution, and it's rather a unique distribution. It's one that is characterized by not so much the number of trials that we're considering, but some type of a limit or interval of time or space. For example, the number of errors in the pages of a book that you might read. The pages would be that limit of space, and the number of errors would be what we would be counting and find probabilities for each. Could be the number of phone calls we might receive in a day. So the time period of a day is going to be that interval, and then how many calls we receive would be kind of the outcomes of the trials. So we look at it just a little bit differently. Deciding if something really fits a Poisson distribution isn't something that we tend to spend a lot of time on in this course. In our options course, we would have to look at a situation and say, I think this is Poisson. But here we're usually told it's Poisson or assume it's a Poisson distribution and work with it from there. Another characteristic is typically that the probability of something occurring is rather small, maybe under 10%. You're probably not going to get a lot of errors on most pages of a book that you would read. So let's take a look at the Poisson distribution. As a function, as an equation, it's this. The probability that the random variable takes on some number x is going to be m to the x e to the negative m over x factorial. That's rather complicated. We don't even try to derive that in a course like this. Again, it's left for a further course. Now, all of this is dependent upon x being 0, 1, 2, 3, and so on. So it could conceivably get as large as you'd like, but typically they're going to be a very small number. We might look at it mathematically and realize that if x is really, really big, we've got a number to the x power over x factorial. And we also have this number, which would be some constant. But the factorial would kind of overtake the numerator, and it would kind of go to 0. Probability as these numbers get larger and larger tends to go down, down, down. Now, as far as the parameter is, you can see that m is kind of the key to this. I know what x is, I know what e is, but what is m? Well, as you might guess, m is the mean. So if you were to do an experiment and find a whole bunch of pages of the book and found the mean number of mistakes was 2.3, well then the mean is 2.3. What's very interesting about these, that hurt, is that this is also, m is also this, which we may remember as variance. So the mean and variance are the same in a Poisson distribution. So if you're asked to find one, you're really asked to find the other. And if you're given one, you're really given the other. And that's rather important to remember, because we know that standard deviation and mean, even if we go through variance, is one of the things we like to deal with and work with when we're dealing with probability in our statistics. So let's see how that all plays out. Let's come up with an example. Let's say that I have a situation where I want to find m. And what I'm given is some Poisson distribution such that the probability that the random variable takes on 1 plus the probability the random variable takes on 2 equals the probability the random variable takes on 3. Now, as I mentioned before, most of what we do in this course isn't so much situational or data-based. It's more the mathematics behind it. Not so much about why this works, but what we can do with it. So this is really a setup just to make us manipulate that kind of function. So if I were to do so, I just have to translate each one of these. The probability x takes on 1 would end up being m to the first power e to the negative m over 1. Second would be m to the second power e to the negative m over 2 factorial, which is 2. And that's going to equal m cubed e to the negative m over 3 factorial, which is 6. So as we take a look at that, it doesn't take too much time to realize that, let's just say I multiply everything by 6. I end up with 6m plus 3m squared equals m cubed. Now the other thing about it is both sides have this e to the m, so that can go away very quickly. And now I'm just set with trying to solve this equation. And if I do that, maybe I could write it as m times, would be m squared minus 6m minus 3. And set that all equal to 0. And as I set that equal to 0, we know that m can either be 0 or m could be, using the quadratic formula, 3 plus or minus, radical is at 33, all over 2. Can check that work. Now one thing we do want to make sure of is that m is greater than 0. I don't want a mean to be negative. That wouldn't make a lot of sense. So what I found are the possible values for m. Of course, if there are never a mistake on a page, for example, everything is the same, it's all 0, this is kind of a trivial situation. I don't really want to think about it too much. But if I would do these calculations, I realized 1 could be negative, so I might take that away. And then I could figure out what 3 plus radical 33 all over 2 is, and I end up with my value. So that is basically what the Poisson distribution is about. There are a variety of questions that, again, ask you to just either find m, or if you know m, find some different probabilities. I didn't want to get through some of the simpler examples because really they're just coming down to, if I want to find the probability x equals 7, and I happen to know the mean, it's a pretty simple calculation. Other than that, I think you should be set to at least look at the problem set from 28F. Soon, and probably before break or the first day of break, I am going to give you a discrete statistics handout as a homework component. Not necessarily that it's due right away, but I'd rather give it to you as you go into your spring break, so if you do have the time and want to work ahead. It will be due soon after we come back from break, so hopefully you will take the time to work on it. Whenever you're done with it and want to get it back to me, you may do that. Meanwhile, enjoy your spring break if you're doing anything. I will be grading your IAs, and we can still stay in touch. So send an email, send a message, get a hold of me if you have any questions. If there is a case that there are some of these problems you'd like to see, I can always set up another video and post it and let you know when I've done so. So if there's nothing else, enjoy the rest of your day. Bye-bye.